Hello, math people. It's Mr. Kingsbury coming to you again. Once again, these are not notes. These are just examples that I'm doing. Actually, I'm just going to do one example. We learned a skill during Unit 4 here on the calculator where we can type a couple equations in and use the calculator to find a solution to the equations. Let me elaborate on that. What we've been studying are systems of equation. That's two or more equations with two or more unknowns. And the systems we've been looking at have a quadratic and a linear equation in them. So at first we were just writing them, but now we need to actually solve them. Now, if you go back to Algebra 1, when you talk about systems, one of the first things that we discuss is that the solution to a system of equations is where, graphically speaking, the lines cross. All right, so if I have a graph, here's my coordinate plane. What's up? We're looking at where a parabola and a line cross. We want to find these. Now, we discussed in class that when you have a word problem, like what's on this worksheet, some of the answers may not work. In fact, most of the time, the graph that you see, actually one of these intersections is over on this side of the this side of the y-axis, on the negative x side, and its value isn't going to work at all. In fact, I'll demonstrate that here in a second. We'll talk more about that. And so we'll be looking for the one with a positive x value, and I'll get into that in a second. Essentially, then, what we can do in the calculator is graph our two equations and get the calculator to find their intersections there. So I have this one, and I picked one that's a little bit easier. I was going to do question 1, but it has this nasty fraction in it, and I just thought it would be easier if we did question 2. So here's question 2. We have a baseball that's thrown in the air, essentially, and the height of the baseball, h, at time t, can be given by this equation here. Then this guy named Jonathan, he's like, I'm awesome, so I'm going to shoot this thing with a paintball gun. And the trajectory of the paintball is given by this. The question is, how long will it take the paintball to hit the baseball, and at what height will that take place? So what I'm going to do is use my calculator to find both of these answers. It's actually pretty easy. Step 1, you type the equations in, right? Type the equations. It would help if you could see what I was writing, huh? Type equations into y equals. Whoops. Not sure what that was. Step 2, this is what you push. You press second, trace. You choose option 5. You use your left and right arrows to the intersection. And then you hit enter 3 times, and it will give you the answer. Let me show you. So here's my calculator. All right. Hello, calculator. I'm going to hit y equals, which is right here. It looks like I got some stuff in there, so I'm just going to clear that stuff out by hitting clear. Yeah, go figure. We've got 2 equations. One of them appears to be right here. Kind of hard to see. So I will type it in. Actually, maybe we can do this. Aha! Then you can see what I'm typing in. So I've got -3. I have to use x. I can't use t in the calculator. It won't let me. I have to use x. So -3x squared plus 8x plus 5. And then I'll hit enter. And we'll plug the other one in. Yeah. We got 2.5t plus 1. Remember, I have to use x, not t, plus 1. And that's awesome. So I'm going to hit the graph button, and we'll see if we can't see where these line up. And it looks like we've got one intersection here and one intersection here. Now let me walk through the buttons really quick. I'm going to hit second, trace, and I'm going to choose option 5, intersection. And you'll notice that there is a blinky cursor that pops up. I need to put that thing close to an intersection. It doesn't have to be right on it. Like you can see, I'm not actually on the intersection, but whichever intersection it's closest to, that's the one that the calculator will find. Also, please notice at the bottom it says first curve. What we're about to do is explain to the calculator what the first graph it needs to use is, what the second graph it needs to use is, and then we're going to say, okay, go ahead and find the intersection. So first curve means, what's the first graph we're going to use? Well, we're on it, so that's good. Enter. And if you'll note, my blinky cursor now jumped down to the other line, and it says second curve. So I'm going to hit enter there, and then it says guess. I don't know why, but you hit enter again, and it will come up with this intersection. You can kind of see the cursors right there at the intersection, and this is my intersection. Now, I have a problem with this. According to my word problem, the x-axis is time, and this is telling me that the baseball is going to be hit by the paintball at negative 0.56 seconds approximately. The last time I checked, there's no such thing as negative time. So I can't use this. This intersection's no good. I need to find the other one, and we'll go from there. So again, I'm going to hit second, trace 5. This time I'm going to use my right arrow and get close. And just to prove to you, you don't have to be on it. I'm going to go way down here. This is the closest intersection. So when I hit enter 3 times, you'll notice the cursor goes back up here. And this time I have 2.39 and 6.98. That's going to work. So we'll go 2.39. I believe it was seconds. Yep. And the height is in feet. So that would be this, 6.98 feet. And before I leave you, just a couple words of advice. For starters, every quadratic system like this will have 2 intersections for the most part. It's possible that there could be no intersection or one, but we're not going to give you an example like that. Ultimately, in reality, there's usually 2 intersections. When you're dealing with a word problem or a context, you want the one that has a positive x value. As I mentioned before, the one with a negative x value isn't going to work because you can't have negative time. Secondly, I want to point out what it says here at the bottom. I've run into a problem where a number of my students are hitting second and trace and 5 and then arrowing really close, and then they're going, oh, mine's really close to yours, Mr. Kingsbury, but it's not quite the same. Well, this doesn't say intersection. You haven't hit enter 3 times. So unless it says intersection here, you need to keep hitting enter. That's very, very, very important. Okay. Lastly, I want to go back to the word problem thing. If I just give you 2 straight up equations, no word problem, no context, no reality, it's just pure math, I want you to find both of them for me. And that's how you do that in a calculator. Not a big deal. Pretty straightforward. Hopefully that clarifies some things. I will see you in class.